What's up, everyone? Back again with another Tesla mechanical design engineer interview question. So in this question, in a turn, a driver has reduced their speed by 13 miles per hour over 1 second and continues to decelerate at this constant rate. At one instant in time, the 1,000 kilogram vehicle is traveling at 45 miles per hour. Are the tires mu equals 1.1 sliding against or sticking to the road? So we're going to break this problem into 4 steps. Step 1 is to draw a diagram. Step 2 is going to be gather the important information that we need to solve this problem. Step 3 is going to be, based on that important information we've gathered, identify the equations we're going to use to solve the unknowns, and those unknowns are going to reveal the answer that we're trying to come up with. And finally, step 4 is to review the problem, go back and read the problem statement, and answer the question. So, is the car sliding against or sticking to the road, the car tires? Beginning with step 1, just by inspecting the diagram that we're given, we know this is an angular motion problem. So in the problem statement, we're told that at one instant in time, the vehicle is traveling at 45 miles per hour. This is going to cause a pull of inertia in the direction that the car is traveling. But because we're going around a curve, there's also going to be a centripetal force, which is pulling the car towards the center of the circle, in addition to a centrifugal force, which is the reaction force to the centripetal force, and it's essentially pulling the vehicle away from the curve. So step 2, let's identify the important information in this problem. We know our acceleration is negative 13 miles per hour per second, our mass is 1,000 kilograms, and our velocity is 45 miles per hour. The coefficient of friction we are given is 1.1. Moving on to step 3, identifying the equations and solving our unknowns. Based on our diagram, we see that this is a force problem, so we're going to be using equations of force. For angular acceleration, this means acceleration is equal to velocity squared over radius. Now to solve our centrifugal force, we substitute the first 2 equations, and we get centrifugal force is equal to mass times velocity squared over radius. Our centripetal force is just equal to friction. In this case, friction is equal to mu times our weight, and weight is just equal to mass over gravity. Now we can set our equations for centripetal force equal to centrifugal force and solve for our max velocity, which is equal to the square root of mu times gravity times radius, and in this case that's equal to 23.2 meters per second. On to part 4, reviewing the problem and answer. We need to know the max velocity in miles per hour, but in part 3 we solved it in meters per second. So to solve it in miles per hour, we can use this simple conversion, 23.2 meters per second times 3,600 seconds in an hour times 1 mile over 1,609 meters, which tells us that our max velocity is 52 miles per hour. Because 52 miles per hour is greater than 45 miles per hour, which is our velocity, we know the car is not going to be skidding. It's going to make it around this turn safely. And there you have it. Another Tesla mechanical design and engineer interview question solved. If you found anything wrong with this, please leave a comment below. This is my second video. I hope they're getting better each time, and I hope to get them out on a more weekly, regular basis. So hope you enjoyed. Thanks.